Hello friends, I welcome you to my YouTube channel MacPM. So in this video we will solve a numerical problem which is based on the columns which has eccentric load. Okay, so let's read the problem and let's note down the important parameters. And if you find this question difficult, then I request you to please go through our playlist and start from video number 1. Okay, so a column of circular section is subjected to a load of 120 kilonewton. So eccentric load means this column is loaded like this. See, it is not in axial direction. Okay, it is away from this axis by distance a, which is called eccentricity. Okay, so P is 120 kilonewton, means 120 to the power into 10 to the power 3 newton. The load is parallel to axis. Okay, this load is parallel to its axis, but eccentricity by amount 2.5 mm. So this E is 2.5 mm. The external and internal diameters of the column are 60 and 50. So this is the cross section, and this is internal DI and DO, external diameter and internal diameter. So DO is 60 mm, DI is equal to 50 mm. If both the ends of the column are hinged, both the ends of column are hinged and column is 2.1 meter long. Okay, so length is equal to 2.1 meter, which is equal to 2100 mm. Now determine the maximum stress in the column. Okay, take E is equal to 200 into giganewton. Giganewton means 10 to the power 9 newton per meter square. Okay, so it can be written as 200 into 10 to the power 3 newton per mm square. Okay, now one thing is given that both the ends of column are hinged. So both the ends of the column are hinged. It means L effective is equal to L. Okay, so this we have to keep in mind. Now what is the formula? Sigma max is equal to P by A in case of eccentric load. Okay, P by A plus P into E into sec LE by 2 into root P by EL divided by Z. You can find this formula in any book where the column is loaded eccentrically. Okay, so we have to find the things which are not known to us. So P is known to us, area is not known, so we will find A is equal to pi by 4 DO square minus DI square. So it will be equal to pi by 4. Outer diameter is 60 mm, so 60 square minus 50 square. Okay, so you will get it as 863.9 mm to the square. Okay, this is our area. Now what will be the I? We have to find Z, section modulus, which is equal to I by Y. So we will find I, moment of inertia, is equal to pi by 64 d to the power 4 do to the power 4 minus di to the power 4, which will be equal to pi by 64. Do is 60 to the power 4 minus 50 to the power 4. If you will calculate it, you will get 3 2 9 into 10 to the power 3 mm to the power 4. Okay, so this is the value of I. Now section modulo Z is I by Y. Okay, so what is the wide maximum distance of the fiber from the center, which is equal to d by 2, diameter by 2. So it will be 329 into 10 to the power 3 divided by diameter is external diameter is 60, so it will be 30. So if we divide it, then you will get 1.0975 or 109.75 into 10 to the power 3 mm cube. Sorry, there is some mistake. If we divide it by 30, then it will become 10.975 into 10 to the power 3 mm cube. Okay, so this is the value of Z. Now what is value of sec LE by 2? Sec LE by 2 under root P by EL. If we find this value, then we will get sec L effective is equal to L, which is 2.1 meter, which is 2100 mm. 2100 divided by 2 under root P. P is 120 into 10 to the power 3 Newton divided by E. Value of E was 200 into 10 to the power 3 into L. L again is, sorry, this was EI. I was, sorry for the mistake, I was 329 into 10 to the power 3. Okay, so from here we will get value of sec this thing. It will be equal to sec 1.4179 radians. This value is in radian, so we will convert into degrees. So how to convert? 1.4179 into 180 by pi, so it will be equal to 81.23 degree. So sec 81.23 will be equal to 6.566. Okay, so if we put all the values, then you will get sigma max is equal to, we already calculated this value. We will put P by A, which is equal to 120 into 10 to the power 3 divided by area was 863.9 plus P into E, 120 into 10 to the power 3 into E was 2.5 into sec, this 81 was 6.566 divided by next one Z. So value of Z was 10.975 into 10 to the power 3. So if you simplify and calculate this, then you will get 318.38 mm to the power 2, sorry, Newton mm square. Okay, so this is our value. So I hope you understood how to solve this problem, and there was nothing, only we have to remember the formula and we have to put all the values here, and this formula is little large to remember. but I hope you can remember. And just put all the values, and you have to take care of the units only. There may be that mistake that you are keeping somewhere mm and there may be some centimeter somewhere else. It happens usually. So first of all we have to convert everything into mm, everything into meter, and after that we have to put the values, and then we will get the correct answer. Okay, so I hope you understood this problem. If you have any doubt, then you can ask in the comment section. Thank you for watching this video.